Rinki Murphy talking about resilience. Thank you. 15 minutes.
Thank you very much. I'd like to talk about enhancing biological resilience to type 2 diabetes and obesity, and Tony has set the scene very nicely here. I'll be focusing on gut hormones and gut microbiota and the important role they might play in keeping people on this side of the BMI distribution and free of diabetes. So I'd like to reiterate that obesity is not simply due to poor self-control. There are powerful biological urges, as we've all heard, hunger being a major part in why we eat. And the two sensations of satiety versus hunger are really important here, and the level at which people feel those varies in the population. So we've heard how the signals or the sensations of hunger versus fullness are analysed in the brain, and a lot of the genetic studies that have been done to date on trying to explain the population variation in BMI show that there are variation in those in the genetic code that responds to these signals. Now these sensations are informed by the hormones that are released from the gut predominantly. And the major hormone for hunger is ghrelin. We've only got one hormone that signals hunger that we know of, but we have several hormones largely arising from the gut that signal fullness. And that is because our default position is to remain hungry. We can't accidentally forget to eat and die of starvation. That would not work. Now, when we diet and restrict our calories in a number of different ways, what happens to the hunger hormone is that increases and our satiety or fullness hormones go down. So our biology is stacked up against us to actually lose weight. And so ultimately most diets fail because people feel hungry. When we move to the situation of bariatric surgery, however, what we can learn from patients who have had various types of obesity surgery where the stomach is disconnected from the passage of food and the gut's altered in its anatomy is that these hormones are actually going the way we'd like them to. Ghrelin reduces, that's our hunger hormone, and a number of the gut hormones that signal satiety are increased. So people feel more satisfied eating less, which doesn't occur when you try and do that with dieting. So what has happened to these hormonal targets, and how are we trying to or capitalise on them in order to increase the resilience of people who need that? So already several of these are targets of drugs that we use for treatment of diabetes. So exenatide and liraglutide in red has recently been released for the treatment of obesity. They have modest effects, and we all know about insulin, amylin analogues and others. However, the problem with these are that they are hormones that are not bioactive orally, they're expensive, you often have to take them multiple times a day, and the bottom line is they're very modest in effectiveness. Now, if we could recapitulate bariatric surgery and lose 20 kilos, then that might be worth it. But for 5 kilos of weight loss with liraglutide at a cost, it clearly isn't. So what we need is more efforts on novel peptides and novel formulations that would make this a viable option for endocrinologists like myself to be able to offer people options. And two groups that are studying this in the Maurice Wilkins Centre of Biodiscovery, firstly, Professor Margaret Brimble is working as an expert biochemist who works on synthesising new and existing molecules with modifications to make them more potent, like these hormones that are active for feeling full. And potentially Professor Debbie Hayes, who whose group is really interested in the receptor signalling and G-protein coupled receptors, which are the targets of these hormones that signal satiety, and their efforts combined could produce some exciting results in the space of peptides that are more potent than the ones we have currently. And to get around that issue of delivery and subcutaneous injections, no one likes taking injections daily. There is a company called Intarsia for whom Debbie Hay, amongst others, consult for, in terms of coming up with a novel delivery system to enable the activity of these gut peptides to be more active up to 3 years per implant. Now, those types of solutions potentially, and there is some preliminary data that was presented last year at the ADA, and this type of formulation being inserted by endocrinologists in the outpatient clinic to actually cause a more marked weight loss and a better result due to better adherence and offer options. Now I'm going to switch to trying to harness the power of gut microbiota, and the setting has been set quite nicely with Professor Cupfield's talk relating to these organisms that have some important implications for human health. Never before have we had the technology or the next generation sequencing ability to actually characterise them in the detail that we are able to today. And this is just a cartoon indicating the complexities with gut microbiota research. Now, at the top here, there is a number of factors that are known to affect the microbiota, and things like genetics, birth root, geography, hygiene can all have effects on changing microbiota, so it's very difficult to disentangle cause versus effect when we observe changes. Overlay on that, the differences in microbiota when we go from left to right through the time course of birth to older age. The microbiota changes even in the healthy individual when they're born to becoming more complex and stable. Usually in the first 3 years of life, that's quite it's changing rapidly and then becoming more stable. So the efforts are trying to understand what is is associated with health and what is associated with disease, and most importantly, what is a cause and what is just an effect of having the disease. So our efforts in this area have been to look at samples from about 400 kids born in Auckland and Wellington, thanks to a study led by Professor Ed Mitchell and Dr. Kristen Wickens in Auckland and Wellington respectively, in which they did a prevention of eczema and atopy study, and their offspring, and there were samples collected from the offspring at birth, 3 months, 12 months and 2 years. And thanks to the efforts of Soshi Morgan, we've managed to start cataloguing, and the details are not important here, but these are the types of microbiota that are changing over time, and on the right, what are they doing? So who is there and what are they doing over that period, with the hope to disentangle what factors these might have in the early life acquisition of gut microbiota. And the eventual aim is to working out what are the good guys and what are the bad guys, and how can we increase the good guys. And this leads me to probiotics. So this study was actually looking at the impact of probiotics in pregnancy with outcomes in children. And probiotics is currently a multi-billion-dollar industry. And the advent of probiotics actually preceded our ability to study the scientific evidence as to how they worked and how effective they were. Now, the regulations regarding health claims on probiotics and supplements is very liberal. In some settings, there's a bewildering range of health claims made for consumers who purchase them with the hope that they will do everything from extending lifespan to improving memory and immune function and beyond. But buried in amongst that is some very real effects. And one of the more carefully conducted scientific studies was this one, in which researchers from the University of Auckland and Wellington have randomised women to either taking probiotic Lactobacillus rhamnosus HNO1 strain, which has been developed by our dairy company Fonterra, and seen what happens to gestational diabetes. And what we found is quite a striking reduction in the outcomes of gestational diabetes in this study, and we're keen to try and see whether this works in a wider non-pregnant situation. And so we're trying to combine the effects of two gut microbiota targeted approaches. One is intermittent fasting, to see if that produces a synergistic effect of what is seen by L. rhamnosus alone. We also want to study what L. rhamnosus is actually doing in the gut, and with that very important cohort of over 400 infants, we are studying the impacts of various factors on gut microbiota acquisition. And as I say, you do have to take into account the effects of time and aging. This is a picture of how the different gut microbiota are composed of, and these rings around it replicate or indicate what these factors do. We've already heard about the changing effects with age, followed by the ring about caesarean section, followed by antibiotics early in life. And what we've noticed for probiotics, that's sort of where the arrows are pointing, they have a very specific effect. And for L. rhamnosus, it increases lactobacillus and it decreases bifidobacteria. It doesn't seem to change the overall composition a great deal. Now, if we contrast this with studies from bariatric surgery in the stable adult environment of gut microbiota, stable in the obese state, we actually get quite different results. And this is some pilot data we have on our first 14 participants. And we're seeing quite marked changes in a number more of the composition of gut microbiota is being altered more substantially here. And we're just working our way through the rest of the stool samples we have in a larger cohort to work out whether the gut microbiota is associated with things that we actually care about, which is satiety, gut hormone levels, and which signal weight loss and type 2 diabetes remission. So with the hope that this will all inform more intelligent design of probiotics in the future, with low risk, and add to the options that we have to alter biological resilience to type 2 diabetes and obesity. So to summarise, I'd like to just re-emphasise the potential role of gut hormones and gut microbiota in promoting resilience to type 2 diabetes and obesity, and some possible effects of trying to generate more effective gut hormone analogues, more scalable delivery, much like settings like contraception, testosterone replacement that endocrinologists are more familiar with and find that they're more success with. Then this also a hormonal condition of obesity that has been unfortunately hasn't had those therapies available. So the more effective next generation probiotics and potential synergistic effects with targeted design of dietary approaches are, in my opinion, possible contributors to reducing the diabesity crisis. So thank you for the opportunity.
Thank you, Rinki. We have time for one question, and pressing question from the front.
Rinki, thanks for that. I was just intrigued with the reasoning behind intermittent fasting and probiotics. What's the link there? Why look at that in combination?
I'm going to repeat the question too.
So why choose intermittent fasting to test along with probiotics? There is some evidence of people who go on very low calorie diets, which are around 600 calories a day, that radically changes gut microbiota, and that resembles a more favourable state. So the rationale behind that is that if we can do that intermittently and inoculate the gut microbiota at a time when that is already changing, that potentially the effects might be amplified.